Happy or boring days are going on? What type of days are going on? Can anyone text? Live streaming is launched. Boom. So we are live now. Okay, everything is okay. I'm ending the poll. Yes. So it's working. We are live now. It's working. It's working. We are live now. So some students are texting me. Yes. So this is what Parth Patel have texted me. Sorry, Parth, I haven't seen your text message here. Good evening, JNV. Bagalkot students, JNV. Okay, good evening, Tirath, and good evening, JNV Tumkur students. Okay, happy, good. So now I'll be starting it. Yes, it's working. No, everything is fine. Audio is good. Okay, cut it. Let us remove this live streaming. It's working. Rahul, hi. So Rahul on the YouTube have texted hi. Let me tell him yes, hi. Okay. Yes. So everyone has replied. See, Parth, I am from basically Rajasthan. Now I'm currently in JNV Mysore. Okay. Serving here. Is it fine, students? Okay. So are you ready for the session? Everyone is ready for the session? Are you ready for the session or not? Are you ready for the session? Yes or no? Send me some emojis. Yes, no, yes, no. Anything. No, no emojis. Sir, we don't like emojis. We don't like. Okay, JNV Bible students have to send a tick. Okay. Okay, I'm stopping this video. Okay, now look carefully on the screen. Okay, so I'm showing you the contents. First of all, we'll go through the contents of today's class. What are the contents of today's class? Okay. Yes. Yes. Madiha have also joined. Okay. Okay, students. So let me tell you that I have completed my master's in physics from NIT Suratkar. Okay, that's fine. I think this much of the introduction is fine. My name is Abhishek, and all these things I've already told you. If there is any issue in the speed or audibility, voice, I mean, if the voice is low, you can text. If high, no problem. You can reduce the voice from your mobile phones. Okay. So Newton laws of motion. Newton laws of motion. We'll solve the numericals based on Newton laws of motion. Okay. Got it? So students, today's session will be completely numerical based session. What kind of session? Numericals based. So we'll try to solve say 7 to 8 numericals. Average, somewhat advanced, good, average, advanced, somewhat. Okay, not a lot of advanced numericals. So we'll try to solve 7 to 8 numericals at least. So class is up to 7:45 and we'll solve. Got it? Today's session is what? Numerical based session. Okay, guys, so are you ready? So what I will be doing is this. What is the method is this? I'll be showing you the slide. Once I show the slide, 4 options will be there. A, B, C, D. Okay. You have to tick the option by yourself. I mean, you can send me the option like this in the chat box. I will see it. I will reply. I will give you 4 to 3 to 2 minutes, maybe maximum 4 minutes. 5 is the maximum deadline case. In the 5 minutes, we together have to solve the question, starting with you people, as a time given to allotted to you for the first 2 minutes. Okay. Are you ready? Yes. Yes. Okay. So this is the first question on your screen. This is the numerical number 1. This is Mr. Numerical number 1. Read this numerical and solve it. 3 minutes to you, 2 minutes for me. In 5 minutes, we together have to solve it. Numericals for you. This is numerical number. Sir, S nahi use karte. S is for number of things. Numerical number 1. So it says at any given instant, A is moving at velocity 5 meter per second upwards. So they say like this was a picture of this constrained motion. This is actually what? A pulley block problem. If I write it here in front of your students, it is what? This is just a practice session, okay? Theory will start from the next classes. I mean, we'll continue up. Yesterday, what happened? Spring, everything ended at spring, okay? So today I have also included in this PPT, this for you people in the session, the problems numericals based on spring. But now just see here, this is pulley block problem. Be focused in the class very much. Pulley block problems. Okay. Basically, it comes under the main category of constrained motion. Why I'm writing these things? For you people to recall the theory. If you're having the notes, you can flip back the theory points and you can match with this. I can solve the numerical and text the answers. It is basically from constrained motions. Okay. So here in front of you, a block is given and this block is moving. They say that when I see this block at a particular instant like this block is moving with 5 meter per second up. So now they're asking from you, what is the velocity of the block at that time? What does it mean? It means when you were just looking at this picture of the constrained motion of this pulley block system, you have seen this thing at any time t, this block was moving with 5 meter per second. Okay. And this block was also moving with some speed, but they're asking you, what is that speed with direction? That is, they're asking you, will this block move like this or will this block move down? If they are moving up, then what is the V magnitude for that? If this block B is moving down, then what is the V magnitude for that? This is the question. Solve it. I'm waiting. Then I will solve. Okay. First you solve, then I solve. I'll solve, I mean. I'm waiting, students. I'm here. Text me your answers. Okay. So one of the champion in the class I've texted Parth is C. Okay. So we'll see Parth. Is your answer right or wrong? What about other students? So you don't panic or like feel fear in this online classes at least. Because see, we are here to learn the things. Got it? Yes. What about other students? What about other students? What about other students? Okay, let me see on the YouTube. Are the students solving the question? So yes, I'm just seeing on the YouTube what is happening there. Okay. Okay, students. Let me solve it for you. कैसे करेंगे कैसे solve करेंगे इस question? Sweetie have given D answer. JNV Begelcourt students have given CC. Okay, so let us now I'm solving. Drop your pens. Leave your pens. Which color? Yellow, white? Yellow, sir. Solution. Okay. See, it says I will apply constrained trick here. What's the trick? First thing is this. Okay. Manthan says A, no issues. So you will apply the trick here. What's the trick? First, you will tick the points. This is what point? This first you will pause the trick. You will take a one string here. Okay. So string is what? String is this. This is a trick to solve these kind of questions. Be careful here. Okay. This is one kind of rassi or string. Hindi we say rassi in very pure Hindi, or English we say string. This is one. If there is one string in a problem, we know the tension will be same. Okay. Actually, the concept behind this trick is the work done by the tension. Some of the work done by tension is zero. but I will apply this here. Okay, see it carefully. So mark this contact points on the block. This is this. Okay, any other point? This point. Okay. So if you focus carefully, what is happening when this block, students, is moving up with 5 meter per second? What is actually happening is this, that when this block is moving with 5 meter per second, okay, this pulley also goes up. This pulley also goes up now. So due to this, we can say if this pulley moves up, okay, let us mark the points now. So I will say like this. Suppose this point is 1, this contact point is 2, 3. You have to mark like this. You have to mark the numbers on the contacts of the string where it makes the contact and where it leaves the contact. So string is making contact here also. This string is making, I marked with blue color. This string is making contact here also, 3 also, here 4 and 5. Here it is making contact 6 and 7, and this at point 8. Okay, this is a trick. So after marking the contact points of the string, you will write like this. Sum of all the velocities equals to 0. Sum of all the velocities equals to 0. So V1, V2 plus V3 plus V4 plus V5 plus V6 plus V7 plus V8 is equals to 0. This is a trick. Take one string, mark the contact points of the string on the block on the pulley, put them equals to 0. Now you can see this with your eyes. Carefully, I mean, you can see this. This block is moving with 5 meter per second up. It means this V1 will point will also, because it is in the constraint. If this is my finger, if I'm joining these fingers like this, if I am shifting this finger like this hand is also moving. This fist is also moving. Kind of palm is moving. So finger is moving. What's the reason? Because they both are connected. Similarly, this red point will also move 5 meter per second up if this block A moves 5 meter per second up. Okay. Now this point if you see is connected with this pulley. Okay, so when this block A moves 5 meter per second up, so 4 and 5 also connected with this. Okay, so they will also feel 5 meter per second force, velocity or speed up. Okay, so I will say this V1 will be having 5, this V5 will be having 5 because they're connected to the pulley both. 5, 5. V2 and V3 are not moving because they are fixed with that vertical wall. This is vertical wall, no? So V2, V3 will not move. V6, V7 will also not move because pulley is also not moving. So V2, V3 cancel. V6, V7 cancel. V8, which is this point, is connected to the block. So we'll mark this V8 equals to VB. Okay? Simple. So what's the answer now? If you will solve this thing, you'll get this thing, that is 5 plus 5 plus 5 equals to V8, which is equals to VB actually, the block's B velocity equals to 0. So here we get VB is equals to what? VB equals to minus 15 meter per second is the answer. Okay. So students, if positive y-axis is positive, negative y-axis is negative. So according to the number line system on one dimension, we'll say that VB is equals to negative matlab niche, downward. That is this 15 meter per second is the answer. Okay. No issues, Parth. Students who are trying, it's like best wishes for them. That's good you're trying. You will try. If you make the mistake, you get the mistake. Next time, when you'll try, it will be perfect. If you're not trying, where you will reach nowhere. Got it? So from this, we get answer as A. A is the right answer. Who was that student who has given the A as the answer? Okay, Sweetie understood? Excellent. Manthan S. Bhatt have given the right answer. Manthan, excellent. Very good. Very good. First try. Very good. But for all other students from JNV, Tumur, Kumtumpur, JNV, Babalkot, whatever it is, I mean, okay, Babalkot. So don't, feel bad. The thing is this, you're having few more questions remaining with you. So students, can we move towards the next slide? Can I just show you the next slide now? Next question. Are you ready? Yes or no? If you're happy with this solution, I mean, it's okay. Let us move towards the next slide. Okay, you close the video. Okay. So this is the next question, students. Try to solve it. Next question in front of you, students. Try to solve it. Okay, little bit explanation for solution. This is a block. You can see it's moving 10 meters per second down. So it's not a thread, students. It's a stick. It's a stick. Consider like this. It's a stick, iron stick. Okay, like consider wood stick. It will not break. Due to which it's connected with the pulley. Okay. So what happens? Let me demonstrate you. So what happens? Stick is connected to the. Suppose this my hand is pulley. Stick is connected to the pulley. Okay. So if the block is moving, due to the constraint with the stick, the pulley will also move. Okay. So we will say that pulley will also move. That's fine. So when the pulley is moving, what's going to happen if this pulley shifts? Suppose see, pulley shifts like this up. So here what is happening? Slacking of the thread occurs here. Whatever the string, whatever the thread is there on this pulley, uska slack matlab dheela. Okay. So this some x will pen like lag here, slack here, some x will get lag here, slack here. So that can with that 2x, this block can be shifted. Okay, this is a logical thing. Let me erase this. So when this block moves, okay, it is moving down, it is not moving up. So if it even if it moves down, this block, due to which what's going to happen, it will not slack now because the block, I thought the block is moving up. If the block is moving down, this pulley will come down with this. So due to this, Rassi, I mean the string or the thread which will get taught by is how much, like x here and x here. Okay. So whatever they're asking from you, the velocity of the block B, you have to find. What is your answer? Options are A, B, C, D. Which answer? I will solve it. Wait, just wait. Must take the answer. Solve. I'm closing. I'll close the video, students. Technical issue. Audibility must be clear, no? I'm waiting for a solution. 1 to 2 minutes. So this is what Mr. A. This is what Mr. B. Block A, block B. Okay, we'll see, students, what is the right answer. Just hold on. Okay, just hold on. We'll see what is the right answer. Focus here. If this block is moving, okay, if this block is moving 10 meter per second down, mark the points again. So this point one, contact, see one string is there, which is the string I've shown you. This is the string, no? One string. Take one string, mark the points, contact points. So when you mark the contact points, first point, second point, third point, तीसरा point, चौथा point, fourth point, fifth contact point is this. ठीक है? Okay. Parth, no issues. Okay, no issues. Just be focused here, Parth. Again, same equations. How I will write? I will write V1 plus V2, V3, V4, V5 equals to 0. Okay, let us take the next clean slide. I will write here V1 plus V2 plus V3 plus V4 plus V5 equals to 0. Okay. See carefully. that if we see these points, V1 and V2, if pulley is moving 10 meter per second down, okay, so we'll say V1, V2 are equal. Constraint, no. V1 is equals to V2 equals to 10 meter per second down. Down matlab kaisa? What sign I will use? Since you can see like this pulley is moving down, so it's extending the strings. Okay, in this trick you have to consider this. If the velocities of the points in are in such a manner, or pulley ki velocity is in such a manner that it is trying to extend the string, you will take it as positive. So here you will take it as positive one. I repeat it again. If the velocity of the pulley is in such a manner that it is trying to extend the strings connected, it's trying to pull, no, it's trying to extend it, then you will take those points velocity to be positive. But if it's moving up, then I will take it to be negative. Okay. So here we will take it to be positive, students. If there is some error, don't worry. I will put in the PDF. Okay. So you will consider like this. So we'll write here V1, V2 equals to 10. 3, 4, they are fixed. It is 0. V5 is VB. So we'll write here. I will write here that is 10 plus 10, 0 plus 0. V5 is VB. So from this, you get the answer as minus 20 meter per second. Minus का मतलब होता है students, it will go how? Can I tell? It is minus 20 meter per second. Minus how? What do you think? What's going to happen? It is like this. Okay. I mean minus का मतलब क्या? In this trick, remember this thing. Positive velocity का मतलब है trying to extend the string. Extend the string. If the positive value comes in this trick, it means try to. So previous question we can apply some change if it's required. Negative का मतलब है trying to compress the string. Okay. No issues path. Positive का मतलब extend the string. Negative मतलब compress. Compress का मतलब this block has tendency to move forward. Okay. I will say like this. This block. So I'll make this figure here. So what's going to happen is this, that this block B, kitna mass is? This mass is given, no B, it is B block. And the string here is this with the pulley. Okay. So this point on the string is moving like this with 20 meter per second. Okay. Compressing. Negative means compressing, moving towards. Agar positive hota to away ja. And logically we can think like this, no? कि अगर block नीचे जा रहा है तो of course that block will be moving there. If the pulley connected block is moving down, that block of course will be moving forward. So ये forward कैसे जाएगा? Forward velocity इसकी v होगी, that we need to find. It is equals to what? You know the angle here is given as 37 degree. So angle here is 37 degree. This is the block, mass m. Angle here is 37 degree. String point connected here is moving with what speed? 20 meter per second in this direction. We want the block speed. It will be equals to this. That is, we'll say like this. What you will do? Will you do like this? 20 cos 37 equals to v, or v cos 37 equals to 20? What you will say, students? What you will say? I have to put this 20 cos 37 equals to v, or v equals to 20 cos 37. What you will say? I'm waiting for your answer. Yes, excellent. Who is this student? Yes. Sweetie, your answer is right. Manthan, your answer is right. Very good, students. Why we'll do this? Because actually the block is moving like this. Okay. So uska net effect on the string is this. Constraint hai na? If uska hota, it will lift. Got it? If I'm breaking the component of 20 cos 37 equals to v, what does it mean? It means the remaining perpendicular component 20 sine 37 will do what? It will lift the block up. Block will gain velocity in the upward direction, and the contact force, normal reaction, this block will be 0. And it's not given in the question. They say block is moving linearly like this. towards say negative x-axis for our convention. So for this can only happen when v cos 37 equals to 20 meter per second. I hope it's clear to you. If anybody is feeling any doubt, please text. Okay, so what I told, normal, for normal condition is this. For normal to be not equals to 0, we'll do like this because it is given in the question. Okay, I mean, this is how the question are set. V cos 37 degree will be 20 meter per second. If you see this triangle, cos 37 is equals to base upon hypotenuse, means 4 by 5. 4 by 5, 20. From this, we get V is equals to 100 by 4. This is equals to how much, students? 4 2 8, 4 5. This is what? 25 meter per second speed. I hope it's clear. This is your answer. You will say, sir, you will take this option, that is A. So A is the right answer. Okay? Fine. A is the right answer. Yes or no? Yes or no? Okay. Good. So now we'll moving towards the next question. This question. Students, this question is very, very much similar to the previous question. The trick of breaking the component. Apply this, you'll get the answer. Question is this in front of you. I'll explain you afterwards, not now. Okay, Parth. Solve this question, students. Solve this question. Just 1 minute for this question because it's easy. We have already solved the question based on the previous. I mean, this is based on the previous question. I'm giving you the time to note down, to solve it, both the things, including in 1 to 2 minutes. Okay. So Parth got the answer, got B. Okay, let us see what the answer is, students. Okay. Again, apply the trick. First of all, we'll find the same thread, the same string kind of. So it is like this. This string is same. Okay, let me. This string is same. Good, good. Let us mark the points. First, let us mark first. 3, 4, 5. I think the string is breaked in between. I think the string is breaked in between. Okay. Okay, students, इसमें trick apply करने का इतना जरूरत नहीं है. You will take the half part, the answer will come. Even if you take the half part, because the string is connected in between, even if you take the half part, your answer will come. Even if you take the half part, students, even if you take the half part, your answer will come. Your answer will come. Okay. Suppose, students, let us imagine like this, that this blocks bounces. If the strings are like this, no, we are holding the strings like this. So if I do like this from the pulley, I mean, I'm talking about this P point and this Q point. If I hold this P and Q points in my hand and do like this, in my palms at least, if I do like this, what's going to happen? This block will jump up. Okay. Suppose the velocity with which this block is jumping is equals to say V. It will bounce like this, like impulsive reaction, kind of impulsive reaction. Okay. If you will feel like this. So now what need to do at this point, of course, if this block bounces with V, this will also be V, this will also be V. So we'll say that this point will be V up. So I will compare this component of V along the string, okay, or the component of u, or the component of the string along the v? What do you say? Anybody? Will I break v cos theta equals to u or u cos theta equals to v? What do you say? U cos theta equals to v, or because I want the v, my requirement is v, I'll break this or that. Anybody? Simple hai yaar. It's very easy. You will break u cos theta equals to v. So sorry. My mistake. You will break like this. You will do what? You will do like the students. You will do key v. Anybody? Nobody's answering. You do like this: v cos theta equals to u. So we'll get v speed is equals to u cos theta. That is D is the answer. The reason is this: why didn't you break u cos theta equals to v? What was the reason? Because if you break u cos theta equals to v, it means there is one more effect remaining. But actually the block is not moving there. Block is moving up. So we'll say the upward motion resultant of this block, the resultant motion of this block, that is the upward v, it can be due to the net effect of both the strings. Can be due to the net effect, okay? But so that's why we are saying कि अगर we'll take this projection here, one projection there, either you take here one projection, v cos theta will be equals to u. Either you take here one projection, again v cos theta will be. So net effect will be v there. ठीक है? This is the answer. I hope it's clear. Students, clear है या नहीं है? Okay, now let us move towards this question. This is a very easy question. Okay, now rest of the questions I'll be solving. You just have to see here. If you feel any doubt in between, you can ask, because these are somewhat advanced level, somewhat advanced. Okay. So are you focused on the screen? Yes. So just please focus. So it says objects A and B, each of mass m, are connected by light inextensible cord. They are constrained to move on frictionless ring. So these are two objects, say massive ping pong balls, or whatever you can say, massive particles. A particle having the mass m, B particle is also having the mass m. They are tied, connected with a string which is in a taut condition, a cord, inextensible. It can't be compressed, or you can say extended. Compressed, kind of slacks, it slacks. So they are constrained to move in frictionless ring. This ring is having mu equals to 0. Okay. Now they say like this: the objects are released from rest at the position shown. The tension in the cord just after release will be what? If you're having a circular thing, if two masses are connected with a taut string, if you release this, what's going to happen? There will be some motion. Okay. Chances are that there will be some, it will do like this somewhat. Not like this. From here, we can imagine intuition is this, it will move like this. Okay. So tension in the cord just after release will be what? A common sense is this, it will move like this. The tension in the cord is what? How I will say? Okay. So you can take any of the masses A or B, draw the free body diagram, answer will come out. Tension is asked. No. Tension throughout the string will be same, cord will be same. What is the tension? Let me show you. So now the picture will be like this. This is a solution. Picture will be like this. This is the cord here. Okay. One mass is, you want me to draw with the red color? You can take any of the masses and draw the free body diagram. This is A mass. Mg will be down. This is the B mass. Mg will be down here. Okay. This is B. So if you see here carefully, let us take this color. Tension, tension. Where the blue is? Tension, 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 tension. This is what? We know this thing. Okay, tension is what? Tension acts in such a manner that it try to what? Slacks the string. It try to what? Compress the string. Okay? It tries to what? Compress the string. So here you can see tension, 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 and tension. Okay. Now for drawing the free body diagram of any of the particles, we'll take what? We'll take this upward thing. This. That also only this part. Okay. And we put a tension here. It's very simple. Angle is already given in the question. Okay. You can assume the angle to be, say, is it okay. So what is happening here is this is center. So we'll use some geometry also. Okay. Let me show you the geometry. Geometry will be like this. This is a center point. Okay. And if you see this triangle, this is a chord passing here. Okay. This will be 90 degree. And we know this thing that by property, it is acting like an isosceles. Okay. So this will be 45 degree. This is 45 degree. So I will say this angle here is, these are all masses, students. Don't get confused. These are all masses. Mg down, Mg down. Both are having the same mass. That's why I'm writing it. So we'll say this angle is theta. Okay. Now tension will be what? We have to just take the component and compare with that. Okay. So we'll say mg cos 45 degree, which is theta, is equals to tension. So from here we get the tension as mg by root 2 is the answer. Is it clear? Yes or no? So text in the chat box, reply in the chat box. Is it clear or not? Yes, okay. Good. Okay, students. So now we'll be moving towards the next question. So here we are. So this is 21 number question. So do you want to try or you want me to solve? Okay. So I'll be solving this. If there are some network stuck here, so I'm closing my video. Okay. Okay, so be focused here. I'm solving this question. So you can see here there are two masses, capital M and small m. Okay. So there is just one common string here. This I'm showing with blue color. Okay. So just watch here. See this. I hope you're able to see. Okay. So now let us take this small m mass. Okay. So if we write the tension components here, it is like this: T, 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 T. This is also what? See, if we connect these two parts here, there are what? Different kind of tensions here, na? Because the string is different. So let me write this concept here. If you are having two strings different, then tension also changes. Tension is what? An electromagnetic force. Okay. So if you are having two strings different, then the tension will also what? Tension will also change there. Its value will change. Okay. So if we see it, this figure, okay, let me draw it on the next slide. Solution here. So let us consider the first part there. This is what? 45 degree mass M. So it's like this. 45 degree where? 45 degree here. 45 degree here. And this is mass M. Mg down. Okay. And this is what? Perpendicular. So if we mark the tension here to be T, tension here to be T, of course, this complete angle is how much? You can see here the complete angle is 90 degree. 90 degree. This is also 90 degree. So this will be what? 45 degree. Okay, I'm solving fast. If anybody is having any issues, you can ask, because we are not having a lot time remaining, because we are having 4 more numericals to solve. Okay. So this is what, if you break the components, T cos 45 here and T cos 45 here. So you'll get this answer, that is T cos 45, T cos 45 equals to mg. So this is equals to how much? 2t cos 45 degree equals to mg here. Okay, so when you will solve this thing, you will get the answer as this. That is 2t equals to mg by cos 45 degree. So from this we get the answer. T is equals to mg by cos 45 degree multiplied by 2 in the denominator. Okay. So from this we get the answer as T equals to mg. Cos 45 is how much? 1 by root 2. And what was the next thing? 2. So this is equals to mg root 2. So from here we get this T equals to mg root 2. Now if you just focus on the next string here, देखो कौन सी string, ये वाली, this string, just be focused here. So this string is connected with this capital M mass at this point. Okay, देखो यहाँ से from this to this the string is common, but when it is just meeting at this point, a new mass is there, capital M. So from here a new string starts. You can see this thing, observe this thing carefully. Is it? Yeah. So see, we'll mark a new tension point here, that is equals to capital T dash. Okay, again you will solve this. Here it will be same, there will be no change here. Okay, so see this now, when you will solve for this T dash, you will get one component here, that is equals to T dash cos theta, and at down the force will be what? If you draw the FBD, this will be equals to capital mg. Okay, and the above will be T dash sine theta. I'm writing this thing here only. Okay, so just compare the equations. This angle will also be theta, so this will give you T cos theta equals to T dash cos theta. From this you'll get T dash equals to T, the same it's coming. Okay, it's coincidence, but actually it never happens. Okay, T dash equals to T. So what you have to do, just create an vertical equilibrium and horizontal equilibrium. You'll get the answers. So I will write T sine theta equals to capital mg. And you already got one point, that is T equals to mg. Just put the values, you will get the answer. Okay, I will give you the complete solution on the PDF, but rest of the thing you have to do yourself. Okay, got it? Okay. I will not give the spoon feeding here. Okay, so 24 number question is on your screen. Solve it. If you're able to solve it, that's fine. Otherwise, I'll give the solution. See, it's very easy question and interesting question. You know, it's like animation kind of. So let me read it for you. It says a stunt man jumps his car over a crater. Crater is what kind of thing? It's what? Something bulged inside like concave mirror. Okay. So as shown, neglect the air resistance. So it says here key four options are there. That when this car is on the like top of this circular thing, so during the wall flight, the driver experiences weightlessness, yes or no? And during the wall flight, the driver never experiences the weightlessness. Okay, one of the students have texted A is the answer. Okay, let us analyze the situation. Let me draw this diagram here. So it is bulged inside. Okay, car is at the top. So if you see, if you focus here, this is what? This is a circular kind of thing. Okay, and this is the center of the circle. So what is happening is this is a kind of a particle which is moving around a circle. Okay, so I will say like this, a centripetal force will be there. Is it? See, there's not a lot of thing here. Just you have to put n equals to 0. Normal reaction is 0. Because suppose there is a ground here, and if I'm keeping a block on this, okay. So here n is this, mg is this. If I draw the free body diagram, if this block is in what? Equilibrium, okay. So I will say what? N is equals to mg. Hai, because this block is not moving in the linear direction also, and this block is not moving in the vertical direction also. Okay. So I will say n equals to mg. But suppose this block is moving, say suppose I am holding this block in my hand, I'm like lifting it up. What's going to happen? From the ground, contacts break, or somehow, you know, something invisible energy is there, like it's lifting the block up. Okay. So I will say whenever for a particle, for a block, or for everything, for anything, okay, if the contact goes 0 with the ground, we'll say normal reaction for that is equals to 0. Okay. Yes. So we'll say here that weightlessness condition will be for what? It is equals to n equals to 0. Weightlessness condition is only for the normal reaction when normal reaction goes to 0. Okay. So your answer is right, Parth. Excellent. Very good. Parth answer is right. Okay. If anybody is feeling any doubt, you can text me in the chat box now. We are only having 15 minutes. Okay. Now let us see a very conceptual question. Yeah. This is one of among my favorite questions. Okay. So let us solve this. See what is happening. I will solve this question. Okay. So we are having here how many pictures? A, B, C, D. If you focus on the A picture, what is this? There is a block which is having the weight W. Okay. If you focus on A picture, there is a block which is, okay, you have already given the answer, Teeth. You say that it's D answer. We'll see. So there are 4 pictures, A, B, C, and D. You can focus on the A picture, that is, here there is a block which is having the weight W. This is not mass. Okay, it's already given that suppose it was having the mass M. So here mg is equals to W given. Okay, so what we'll do is that we'll draw the free body diagrams of all the blocks, and then finally we'll compare the tensions. And the tension in the string where the tension is the maximum, okay, so that string is most likely to break. You know this thing. If the electromagnetic force in a string is maximum, that string is more likely to break. Okay, so we'll draw here FBDs. So okay, I'll draw on this slide only. So suppose this is T1, this is T2. Okay, let us make it symmetric. Okay, T1 equals to T2. So I will say T plus T equals to mg. Mg means W. Okay, so 2T equals to W. From this we get T equals to how much? So from here you get T is equals to W by 2. Okay, and if you focus on this string, suppose it is T here. So for this, if I create a symmetric line in between, if this is say theta angle, theta 1, you can see it's like, it's somewhat, it's not symmetric about this perpendicular line. This is theta 2. So if you join this components perpendicular, you'll get what? T cos theta 1 plus T cos theta 2. This is equals to W. Is it right? And let us draw for this. Isme the angles are very far away, but I will take the components like this. Say, okay, let us take T1, T2 for this. T1 cos theta 1 plus T2 cos theta 2 equals to W again. Okay, and for this theta 1 and theta 2 again, I will take T cos theta 1 plus T cos theta 2 W again. See, I can just by seeing, I can tell like this, this tension in this picture, that is A picture, will be the maximum. The reason T equals to W by 2. But if you see other angles, you know this thing, cos theta. If theta is increasing, cos value will also what? Increase or decrease. What do you say? If theta is increasing, will cos value increase or decrease? No. If theta increases, cos value decreases. You know this thing, okay? Because we know cos 0 is the maximum, that is 1. Okay? So you can see here, if you just focus on the angles, theta 1 is greater than, in the B part, the theta 1 is greater than the theta 2. Okay? So we'll say here that cos value will be less for that and cos value will be more than that for that. Okay? I mean for cos theta 2. So for that, it will not be equivalent to this as it is in A part, that is tension equals to W by 2. Okay, so just by looking for these formulas, we can say tension in A is the maximum, that is equals to W by 2, which is the right answer. Okay, is it clear? So if anybody of you can like text in the chat box, my answer is fine, or you're having any issues in this? Anyone of you can text in the chat box. Answer will be A, that is equals to mg by 2 or W by 2. Okay. Okay, I will give you the solution in the PDF. Now let us see the last question. This is not the last one. Let us see the last. Second last will be homework. Okay. This is a question based on the previous class. Okay, this is from what? Spring force numericals. This is what spring force numericals. Okay, let us solve this. I'll solve this question and then we'll end the class. Okay, this is the last question. So it says like this: we are having a block which is having the mass equals to 3 kg. If mass is 3 kg, what does it mean? If mass is equals to 3 kg, it means the weight is equals to mg, that is 3 into g. Okay, and we are having the 2 springs here. So whenever we take two different springs, we write like this, their spring constants will be also different unless and until it's given in the question. Okay? See, if you're taking two strings, 100% sure tension will be different. Okay, it may be spring constants will take different, but if you see, if you read the question, it says a block of 3 kg is initially in equilibrium. We know this thing. And the two identical springs. So whenever it says the springs are identical, it means spring constants are what? Same. Okay. So we'll take here K to be same. Okay. Now it's very simple. They're asking that at time this was 0, the scene was this. But suddenly what happens? If a spring A is cut, so among these two springs, that is A and B, if we are going to cut with scissor, let me draw a scissor. Okay. So if I'm going to cut this A spring, what's going to happen? What's the result? What will be the acceleration of the block 3 kg? Very simple and interesting question. Okay. So I'm solving this here. Just be focused on the slides. Solution. Okay, white pen. So you're having a ceiling like this. Take two springs. Be focused. Otherwise, you will lose a point here. So this is a mass M, which is having 3 kg mass. I think someone have solved. So you are saying A answer. You are saying C. We'll see. Okay. What is the answer? Just wait. K is a spring constant for this. It may be mano ki K is a spring constant because they are given already identical. Initially, they were at equilibrium. So we'll say like this, forces on the block. Let me draw this free body here. It will be like this. What? K, what is that? X naught, because it's extended. Okay, when the spring is extended, the spring force will be vertical. K X naught. Weight will be what? 3 mg ka matlab kya hota hai? 3 into g. So this is an equilibrium condition, initial condition, T0. When we haven't, like we haven't applied here what? C0. Okay. I will say Kx plus Kx equals to mg 3g. So we'll write here 2k x equals to 3g. So you can get here from this Kx value is equals to 3g by 2. Okay. You're getting the combined value Kx equals to 3g by 2. Got it? Now let us switch back. So they say that when I apply this spring here, I mean that scissor here, if I cut a spring, what's going to happen? Very simple, students. So when you're going to cut this spring, now let us analyze the block. Okay. So what is happening? See, if you cut the string, you are having the two concepts. I hope that you have studied in the previous class the theories and the two concepts related to string and spring. Okay. String में क्या हो रहा था? If there was tension there, okay, this is tension. If you cut a string, what will happen? Tension instantaneously goes to 0. Instantaneously, matlab, I mean at a particular instant, at the same time, okay, it will go what? 0. Instantly, it will go towards 0. But if you're having a spring like this, if you're having a spring, if you're going to cut the spring, FSP force, which is what? Spring force will not go to 0 instantaneously. It will not go to 0 instantaneously. Okay. So for this block, the situation will be this. Force Kx will be acting at a particular instant when this A spring is like cut here. Mg is acting as same 3g, but above forces will also be acting. That is what? That is equals to how much? Kx forces. Okay. So it will, the Kx forces will be also acting on this. So the net acceleration of this block will be like this. That is Kx and Kx. So we'll say the acceleration is equals to how much? Anyone? What will be the acceleration? So now you can find like this. We are having already. Yes. Anyone of you? Is it 0, 3g by 2, g or 2g? Sorry, from this option it is 5, 10, 15 or 0. What is your answer? 5, 10, 15 or 0. What is your answer? See, this is one of the easiest question. If you're having a block 3 kg, upward force is FSP. This is still acting FSP. This is 3g. It is in equilibrium initially. Even if you cut the spring, FSP doesn't goes to 0 instantaneously. You can see this thing. In this, I'm talking about in this spring, FSP will not go to 0. So what do you say? What is your acceleration? Simple, students. It is like this. 3 g matlab 10. This is kx force. It was initially equals to how much? We have already derived kx equals to 3g by 2. So I will write 3g minus 3g by 2, mass of the block 3 into acceleration. You'll get what answer? 3g minus 3g by 2 equals to 3a. So you'll get 3g by 2 equals to 3a. You'll get acceleration as g by 2. G by 2 matlab 10 by 2. 10 by 2 means what? 5 meter per second square acceleration. Okay. So we are having the A option is the correct answer. Anybody is having any doubt? So we are having A option as what? Correct answer. Okay. Yes. So now I'm going to end the class. So if anybody is facing, like anybody is feeling any doubt in this today's session or like any doubts from the previous class, you can text me in the chat box. I hope this question is clear. See, only the main concept in this question is this. At last, the conclusion, the main concept is this here. What is this? That when we cut the string, tension instantaneously goes to 0. But when we cut the spring in the system, spring, FSP doesn't go 0. Okay? So now I'm going to end the class. Anybody is facing any doubt can text in the chat box. Okay, thank you so much for your attendance. And yes, I'm going to launch the poll now. Please participate in the poll. That what is your feedback? Okay, I have launched the poll. I hope it's visible on your screen. Participate in all of these 5 questions. Okay, and then you can leave the class if you are not facing any problem or if you're not having any questions. Okay, so I'm ending it. Bye everyone. You can leave the class. Okay, if anybody is facing any doubt, can put a text in the chat box.